All right, so this we did in class together, but I want to just go over this again as a review, so you don't have to write anything down for this because you should already have it written down. So if I'm going to try to use synthetic division in order to find the roots for this, I'm first going to have to look for any possible rational zeros. All right, so I'm going to try to identify rational zeros. All right, and to do that, I look at my constant term, which is a 6. Now I try to think of all the factors of 6. So that could be positive or negative 1, positive or negative 2, positive or negative 3, and positive or negative 6. Those are all the numbers that can multiply to be 6. And then I'm going to divide that by all the numbers that multiply to be my leading coefficient. So I could do 1 times 2, or I could do negative 1 times negative 2. They would all give me 2. So these are all my possible rational zeros. And if I simplify this, well, the first option would give me a plus or minus 1. And then if I take 1 over 2, we would get plus or minus 1/2. I could take 2 over 1, which would be positive or negative 2. And then I could take 2 over 2, which is 1. We've already got the 1 taken care of, so I'm not going to rewrite that. And now I've got 3 over 1. Just kind of going down the list here. 3 over 2, 3/2. Then I've got 6 over 1. And then I've got 6 over 2, which does reduce to be 3, which we already have, so I'm not going to rewrite that. So these are all the possible rational zeros of this function, right? That was my step 1. Step 2 is we're going to test these values, all right, using synthetic division. All right, and the way that we do this is, again, we're going to make that vertical and horizontal line. And then up top here, I put the coefficients of my polynomial. So up here, I'm going to have a 2, right, because we got 2x cubed, a minus 3x squared, a minus 11x, and a positive 6. And notice I've got 3, 2, 1, 0, so I have them listed in order. I'm not missing any terms. If I was missing a term, I'd have to throw in a 0 somewhere in between here, depending on where my missing term was. Now up here, we can fill in any one of these possibilities, all right? I like to start with the easier ones and then kind of work my way across. So I'm going to test out a 1 to start. And then how synthetic division goes is we bring down the leading coefficient, and then we multiply. 2 times 1 is 2. Add these together to get negative 1, right? Add those to get negative 1. Multiply to get negative 1. Add these, to get negative 12. Multiply these to get negative 12. Add these to get negative 6. Now, whenever you have a remainder here, you know that this is not going to be a rational zero. So 1 is not a rational zero. All right, and you can keep doing this. All right, you can keep doing this until you find successfully one of these values that works. All right, now when you do this, you're going to find a few of these options end up working. But again, you only need one to work before you can go to one of your normal factoring methods. So if we keep trying this, we can try the negative one. I'm going to kind of do this at a quicker speed. 2, negative 3, negative 11, and 6. Bring down the 2, multiply, add, and that's 12. So 1 doesn't work. Sorry, negative 1 does not work. We can test out a positive 2, negative 3, negative 11, 6. Bring down the 2, we multiply, we add, we multiply, we add, we multiply, and again, it doesn't work. Let's try out the negative 2. And again, it's just kind of, you have to just keep testing these out until you find one that works. So we bring down the 2, multiply, add these together, multiply, add these together, multiply. Ooh, well, look at that. Negative 6 plus 6 gives me a remainder of 0, which is what we're looking for. Whenever you have a remainder of 0, you know that this is a rational zero. So the idea is, if negative 2 is a rational zero, that means my graph is going to go through the x value negative 2, right? Negative 2 comma 0 would be an x-intercept. If that's the case, I know that one of the factors of this polynomial will be x plus 2, right? We're used to kind of doing this in reverse. But if I know one of my zeros is negative 2, that means that the factored form of that has to be x plus 2. And so then, because I've taken out an x from my original polynomial, that means that I must have one smaller degree for each of my values, right? We started with x to the third power, but since I've factored out an x, right, here's the x I factored out, that means I'm going to have x squareds, x's, and then my constants here. So if I bring down the 2, negative 7, and positive 3, this actually tells me my remaining polynomial, which is great because I know from this that one of my rational zeros is negative 2. And I could keep going. If I wanted to, I could look at this polynomial and I could say, oh, well, the rational zeros could be plus or minus 1, plus or minus 3, over plus or minus 1, plus or minus 2, right, based on the 3 and the 2 here. So I could do this whole process over again, and then I could test these out, right, put in a 1, and then I could test out the 2, the negative 7, the 3, and I could see if that's going to work. I could keep going with this process until I'm down to just all my factors. But we don't know for sure if we can walk away with that situation, right? We don't know if we have all 3 being rational zeros, all right? We don't know if we have maybe some imaginaries, maybe some irrationals. But what we can do right now is we can look at this polynomial here. This is a quadratic. And I can look and I can actually see that, well, 2 times 3 is 6. So I'm looking for 2 numbers that multiply to be 6, but that add up to be negative 7. And as you can see, we do actually find numbers that work. Negative 6 times negative 1 is 6. That works. And negative 6 plus negative 1 is negative 7. That also works. So I know I'm going to use the shortcut method here. We're just going to take my 2x over negative 6 and 2x over negative 1, right? I get these values from the 2 we found right here. And then we're going to go ahead and we can't simplify the 1 on the right, so that's just a 2x minus 1. But we can simplify this, right? This is just x over negative 3 when I reduce it by a factor of 2. So that gives us x minus 3 as the other binomial. And if I look at all my binomials, I'm going to bring this one down here. We've got an x plus 2, we've got an x minus 3, and we've got a 2x minus 1. So it looks like we're actually going to have 3 rational zeros for this problem. One of my rational zeros will be negative 2, one of them will be positive 3, and the other will be 1/2. All right, so we end up with 3 rational zeros, no imaginary zeros, and no irrational zeros, right? We expect to get 3 solutions because the fundamental theorem of algebra tells me I should have 3 solutions because it's degree 3, right? Let's try another one here. On the next page, letter B, if I look at this one, so I got to think we've got really like a plus 0 back here, right? I don't really have a constant in this problem. So you might be thinking, well, if I don't have a constant and I'm looking for my rational roots, we can take 0 over anything is just going to be 0. So I know one of my rational roots has to be 0, which is correct. However, what I'm thinking, when I look at this problem to begin with, going back to the previous one, when I looked at this, I thought to myself, there is no way that I know how to factor this, right? We can't do grouping, we can't do difference of squares. There's no method I know that I can use to factor this, right? We've got to use synthetic division first to get it into something that I do know how to factor. However, in this one, when I look at this one, I'm looking at these first 2 terms and these second 2 terms, and I see an opportunity for grouping, right? First of all, when I look at all 4 terms, I see a GCF, and I see that I can take out an x from all 4 of these terms. So if there's an opportunity to factor using a method you know, take that opportunity. Don't just wait and assume that you have to use synthetic division for everything. So if I factor out an x, that's going to give me 3x cubed minus x squared minus 12x plus 4. And now when I look at this right here, I do see that I can factor by grouping. So I've still got the x out in front. And now if I look at the first 2 terms, and I group the first two terms, I see that I can take out an x squared, right? From this term and this term, I can take out an x squared. And that's going to leave me with 3x minus 1, right? We can double check by distributing. X squared times 3x is 3x cubed, and x squared times negative 1 is negative x squared. So, all right, so I just did a little GCF there. And then in my second two terms, that second group, I can take out a negative 4. And if I take out a negative 4, that would leave me with 3x minus 1. And notice that's exactly what I want. I want to get these common binomial factors here. So what that means now is we've still got the x out in front, and then I have a common 3x minus 1 that I can factor out, and that leaves me with an x squared minus 4. So x squared minus 4. And I'm actually really close to being done. One last thing is we can factor this because this is a difference of squares. That's going to give me x times 3x minus 1 times x plus 2 times x minus 2. Okay. Now we could have actually done synthetic division for this problem, right? Synthetic division is going to work. Our normal factoring methods are going to work as well. So you could use synthetic division. It would take you much longer if you don't recognize that there's an easy way to factor this. But again, both will get you to the same place here. When we look at our final answer, we can see that 0 would be a solution, 1/3, -2, and +2. All right, and hopefully as you look at this, you can kind of see where we're going with this, right? If we were to think of a graph, we know that 0 is a 0, 1/3, +2, and -2. Those are all my zeros that we just found. I could plug in a 0 for x and find the y-intercept, which would also be 0 at my origin. And if I wanted to, I could look at the end behavior, right? I have 3x to the 4th power, so I know the end behavior has to go up in the same direction, right? And I also know that because it's 3, it's positive, it's going to also, go up instead of opening downwards. Because these all have a multiplicity of 1, I know it's going to go through all of these points. So it'll go through, 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 and through. So our graph is going to look something like that. Might not be perfect, but we care about just going through those key points. So as you're doing these, again, try to think about what the graph might look like when you do this, right? Think about end behavior, y-intercepts, and your x-intercepts. All right, for letter C. When I look at letter C, all right, this is definitely one that I can't do grouping, right? I don't have a 2 and a 7. There's no GCF between the 2 and the 7, and that's going to be different than a 9 and a 6. So definitely can't do a GCF. I can't do grouping. So we're going to have to rely on some synthetic division. So I'm first going to have to find the rational roots. So I'm going to look at my -6. So the factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. In my denominator, I'm going to divide that by the leading coefficient factors. And the factors of 2 are plus or minus 1 and plus or minus 2. So this is actually very similar to the first one that we did, right? Very, very similar. So I already know that these rational zeros are going to be the same ones I have to test out for this next problem here. So I'm going to rewrite that list. I'm going to copy paste that list because we already know what we could have. We could have plus or minus 1, plus or minus 1/2, plus or minus 2, plus or minus 3, plus or minus 3/2, and plus or minus 6. Those are all the possible rational roots. So we're just going to go through this process and start testing them out. Right here is where I would recommend pausing the video and going ahead and trying synthetic division for yourself and just start testing these out and see which of them works. Once you get one that works, then you might be able to use quadratic formula or maybe an even easier factoring method. All right, so pause the video and then go ahead and resume it once you feel ready to go. All right, so if I test out a positive 1 with 2, -7, 9, and -6, bring down the 2, we multiply, we add, we multiply, we add, we multiply. Not going to work. So 1 is not going to be a rational 0. Take -1. 2, -7, 9, and 6. -6. Bring down the 2, multiply, add, multiply, add, multiply, add, doesn't work. Let's try the 2. I'm going to skip the 1/2. I don't really want to work with fractions that much, so I'm going to try the 2. 2, -7, 9, and 6. Bring down the 2. We multiply. We add. We multiply. We add. We multiply. And that's 12. Doesn't work. Let's try the -2. 2, -7, 9, -6. Bring down the 2. Multiply. Add. Multiply. Add. Multiply. That doesn't work either. Let's try the 3. How about? So we get 3 in there. 2, -7, 9, and 6. Bring down the 2. Multiply. Add. Multiply. Add. Multiply. Doesn't work. Let's try the -3. Bring down the 2. Multiply. We add. We multiply. We add. We multiply. I already know this isn't going to work, right? That's -105, -121. That's no good. So let's try the 6. How about? All right, so 6. And it could be where you have these problems that just take you a little bit of time to figure out. That's okay. That's normal. 2 times 6 is 12. We add these, get 5, 30, 39. I already know that's not going to work. That's way too big of a number. Try a -6. We got 2, -7, 9, -6. Bring down the 2. That's -19. This is already way too big, right? So I know this is not going to work as well. So it might have to be a 1/2 or 3/2. Let's go ahead and try out the 1/2. All right, so if I try out 1/2, 2, -7, 9, and 6. So we're going to bring down the 2. 2 times 1/2 is 1. Add these together, we get -6. Half of -6 is -3. Add these together and we get 6. Half of 6 is 3. 9 doesn't work. Let's try -1/2. All right, so 2, -7, 9, -6. Half of -1/2 of 2 is -1. Add these up, we get -8. Half of -8 is 4. This adds up to be 13. -half of that is -6.5. That's not going to work. All right, we're down to the last 2. Let's try the 3/2 and the -3/2. All right, so 3/2. 2, -7, 9, -6. 2 times 3/2 is just 3. Add these together and we get -4. -4 times 3/2 is -6. Add these together, we get 3. This is 9/2. That's not going to be 0. All right, last chance. Here we go. All right, so -3/2. Bring down the 2. That's a -3. This adds up to be 10. That's -15. This adds up to be -6. And that's going to be 9, which also doesn't work. So unless we made a mistake somewhere, it looks like we are not going to have any rational zeros. So if we go to Desmos here, let's just double check our work because we could have made a mistake somewhere. All right. We're going to go ahead and we're going to type in our function. So our function again was 2x to the third minus 7x squared. All right, so y equals 2x to the third minus 7x squared plus, was it 9x minus 6? Let's double check. And we do actually have a rational zero, which is 2. So that means that I made a mistake at 2 here. Let's double check this. So if I plug in a 2, oh, that's why. I apologize, sorry. I forgot this is a -6 at the end, right? So when I wrote this, this is supposed to be a -6 here, right there. And I forgot the negative. So -6 plus 6 is 0. So that does add up to 0. So that is what we're looking for. So we could have really saved a lot of work if I was being careful about my work. So this is a good lesson to all of you, because this is what I see on most quizzes and tests when you guys make silly mistakes. And it happens to us all, obviously, but just be careful, because I could have saved myself 1, 2, 3, 4, 5, 6, 7, 8, 9 attempts just by being really careful with my work. So just be really careful. 2 would have been a factor. Sorry about that. That took a lot of extra time. So hopefully you make fun of me in class, which I'm sure you all will next class. So 2 is a factor. All right. So looking at this, I'm going to erase all of this now. We don't even need this. All right. So I know that if 2 is one of my zeros, I'm going to have x minus 2 as one of my factors. And then I can bring down each of these. That would give me a 2x squared minus 3x plus 3. So now I can look at this and I can try to factor this. So if I look, 2 times 3 is 6. So can I find two numbers that multiply to be 6 but add up to be negative 3? And I don't think we can, right? So because I can't factor this easily, I'm going to have to rely on the quadratic formula. All right, so I'm going to go ahead and I'm going to do the quadratic formula on this. And we're going to go ahead and a is 2, b is negative 3, c is positive 3. So we've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is going to equal positive 3 plus or minus the square root of 9 minus, well, let's see, so 8 times 3 is 24 all over 4. And this is going to be 3 plus or minus the square root of negative 15 all over 4. And the only other thing I can do here is 3 plus or minus I square root 15 over 4. So if I'm looking for all my roots, one of my roots we already found initially was 2. So I know 2 is a 0. I know that 3 plus I square root 15 over 4 is a 0. And I know that 3 minus I square root 15 over 4 is a 0. Okay, so I do get 1, 2, 3 solutions, which I should expect to get because I have x to the third power. And then again, this is why I like to use Desmos. I know you guys aren't a big fan of Desmos, but when I look at Desmos, I can clearly see that there's one rational solution at 2. So I used it to check my work, not to do my work, but I used it to check my work, and I did find an error, so I was able to go back and then fix it. Okay, notice it only crosses once. There's not a multiplicity of 3 at all. It just goes through once. It doesn't bounce or anything. And then those other 2 zeros are imaginary. All right. On the bottom here, what I've done is I've written 3 problems. Okay. I would like for you in your notebooks to go ahead and try these 3 problems. Okay. It asks you to find all rational, irrational, and imaginary roots. All right. So I want you to go ahead and there's a second video that you're going to watch, which has me going over these answers. But I want you to try these 3 problems in your notebook first. Work with a partner, see if you can figure it out. And again, don't always assume that you have to use synthetic division right away. Check to see if there's maybe a different factoring method that you could use first to possibly